today's buzzword, right? ChatGPT, all about language models. So in this session, we will be demonstrating how to use the large language models to build applications for your own organization or your own self. I am Dipayan Sarkar. I am the principal data scientist at Quest Learning, and I'll be walking you through this demo today. So before we get into the demo right away, just let me give you a little brief for those of you who are very new to this large language models. I'm sure some of you are already an expert in this field. So what are these large language models? Well, to start with, your ChatGPT is one of the large language models. And simplistically speaking, it takes some text, runs through the model, and gives you some text in return. And that's what your large language model is. If you notice your ChatGPT, which you are using nowadays, you type in something and it goes through the model and it returns you some results, right? Now, there are a lot of applications of LLM. ChatGPT is just one of the application probably, right? It can help you cluster your text or, group your texts into sections or clusters. It can generate text for you, which your ChatGPT is doing it, rewrite something for you. Again, ChatGPT is one of the classic example. It can provide you reasoning. It can summarize your text. Suppose you are going through a research paper or you are going through a lot of content on the website and you say, can you summarize this for me? You can even classify your texts and you can even extract information from high volume of text. And these are all applications of LLM. And the reason why we are conducting this session is we will be demonstrating how to use open source LLM to achieve some of these. So the other thing that we will be quickly looking into is text-to-image models, meaning we give text as an input and we get image as an output. Now, many a times, we get into debate or we keep thinking like, what am I going to do by generating an image, right? So even text-to-image models have very high number of applications. For example, in e-commerce and retail, IKEA is currently using augmented reality systems, and probably in the future, they might be using text-to-image models, which actually help them avoid returns from the customer, right? And that's saving a lot of dollars for them. These text-to-image models can be used in education or building training content. It can be used in VR and AR. Even it can be used in data visualization and storytelling from your data. In fact, some of the popular data visualization tools have already started incorporating text-to-image models, which can actually read your data and give you the charts dynamically. You don't need to drag and drop and do things anymore. Well, the refinement will continue for a while. It's not that we get a very mature product at this point in time, but yes, things are already in pipeline and things are evolving a lot, right? So some of the popular examples of your LLM, you have a GPT, you have BART, you have Bloom, and a lot more. Text to image, you must have heard of DALL-E and your Stable Diffusion. So today what we will do is I will take up GPT-3, which is the model behind your ChatGPT. We will be taking Bloom, which is again an open source large language model. And we will also be taking Stable Diffusion and demonstrate some of the applications here. So let me walk you through the demo, and after looking into the demo, we will see how we will figure out how it actually works. So what we will be doing in the demo is we'll be using a platform called Hugging Face. Okay, now what is this Hugging Face? Hugging Face is a platform where it has developed a lot of transformers, and it also provides you a lot of data sets. Now, what are these transformers? The transformers are basically the models, the large language models. And there are many large language models already uploaded into Hugging Face. So you can right away download them, put in your data, rebuild the model, upload it into your Hugging Face, and right away you can create an API or an application on top of your new model. I repeat again. So if you suppose you take GPT, all right? I take the GPT model, that is a pre-trained model, right? So I put my data into it, I fine-tune the model, so I get a new model now, right? This new model understands my data, right? Now, for example, all of you know that GPT-3 is built up to the data available that was available till September 2021. After that, GPT doesn't know it as on date, right? So what we do is also there might be some data which you have, which is very proprietary, and you don't want to give it to the public, right? You don't want to push it to the cloud or anywhere else, right? So what we do is we can download this model, retrain the model with our proprietary data, and use it the same way you use GPT or ChatGPT, right? Now, if you notice also that there is a bidirectional arrow between Hugging Face and datasets, what I wanted to mean basically is there are a lot of datasets that are custom datasets that are already available in Hugging Face. You can either use those datasets or you can pump in your own dataset and rebuild your model. And once you rebuild your model, you can deploy the model into Hugging Face, create an UI on top of that model, and straight away use it to test your models. And I will be demonstrating all of this today. So just let me go to let me take you to the web page here. Okay, before I get into the web page, let me show you something here. So I will be demonstrating you the usage of GPT-3. Now, what I have done is I have an account with GPT. And if you see here, I have some API keys, which basically means if I am developing an application, I can use my API keys to connect to GPT, use the GPT architecture, and train GPT on my own data. Now, there are, many LLMs, many large language models, but all of these models have their own advantages and own disadvantages, right? For example, if I say GPT is having one disadvantage in terms of saying, it knows everything till September 2021. It was not built on the data which existed after September 2021. On the other hand, Google Bard, is a live model. It can connect live to the internet to give you current information. Now, you might say, oh, that way Bard is better than GPT. Yes, definitely Bard is better than GPT because Bard is connected to the internet live and it can give you live results, right, which GPT cannot. On the other hand, I will show you, in many cases, GPT performs way better than Bard. So it might be, a good option to try all of these LLMs and then figure out which one suits you better. For example, here you see on the GPT, this is a chat GPT. The UI is pretty much familiar to all of us, right? And I ask a question, a hen lays 3 eggs and a rooster lays 1 egg. How many eggs are there in total? Now, GPT says in nature only hens are capable of laying eggs, while roosters do not lay eggs. Therefore, based on biological facts, hens would lay 3 eggs. So there are total 3 eggs. The same question is asked to Bard. And Bard says, if a hen lays 3 eggs and a rooster lays 1 egg, there are a total of 4 eggs. Right? So if you see, in this case, you will be probably relying more on ChatGPT and say, okay, I get a more reasonable answer there. But on the other hand, if you have a requirement which is more current in nature, which is live, happening every moment, I think Bard is more capable of giving you the recent and the latest information which ChatGPT cannot. Right? So that's the reason why we have a lot of large language models. Now, let me walk you through one of the cases here. So this is a Jupyter notebook where I have written a piece of Python code. And what I'm doing here in this, I won't be running all the codes because these models are pretty large in size, in volume. And when I download this module from Hugging Face, or when I retrain my model, it might take several hours. All right. In fact, some of the models I tried building it using Google Colab. It didn't work because the GPU was not enough, and then I had to upgrade to Google Colab Pro. Even that failed. Finally, I had to go into Google Colab Pro Plus for building some of the images with my own data. So these ones are simple ones. I will show it to you. So here, what I am currently doing is I am going to use GPT 3.5 model, but what I will do is I will pump in my own data. So let me go back to this chat GPT, and I will ask something about, can you tell me about OS learning data science mentoring program? And if you see here, it says, I apologize because my last knowledge update was September 2021. Well, we have been in existence since 2019, but very recently, due to certain requirements, we changed the company name to Quest Learning, and ChatGPT is not aware of it. So what I do here is, this is the Python Jupyter notebook. I am installing the OpenAI library, and I also have a key which actually helps my Jupyter notebook shake hands with OpenAI, right? And finally, I have written certain code. Of course, I'm not deep diving into every lines of code, but I will just explain you the code. So what I will do is I will take up certain content from my own program, one of the programs. So I will just, copy it. It's a long para. So I simply copy it. I go back to my Python code, and I enter the complete details of the program. So it says data science advanced mentoring program, for whom it is built, introducing, and how our data science program is structured, and blah, 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 blah. So I simply run this. Now what is happening is basically I am making ChatGPT understand my content. So, and when ChatGPT works, any of these LLMs work, right? You are chatting with these LLMs, you will be playing the role of multiple roles, right? Like, for example, you have an user role, you have an assistant role, and so on. Again, I'm not getting into the details of this. I will be talking briefly about prompt engineering. So what I do is I simply run this, and now this is what exactly ChatGPT is working now. Now, if you see here, I go into GPT, I click on my usage, and you see here, it says that 1st of July, because just before this event started, I was actually, testing my code if it works properly. And it says like, I have been using this. Now, let me tell you, this GPT is not free. So when I'm connecting from Jupyter Notebook or any other applications to GPT and saying that I will give you my data, you train yourself on my data so that I can ask you questions relevant to my data, it will charge you. For example, if you see in the month of May, I've been using it, and it keeps on billing me as and when I use it. But yes, if it is an organizational requirement, it should not be a problem. But now when I say, can you brief me about, let me ask the same question, which I have asked here. I ask the same question to ChatGPT now, and it should be able to, it might take a few seconds. Well, it does take a few seconds here and there, but yeah. So it gives you about, a bit about the program. And in fact, you can ask any questions like, I am a maybe, data science graduate. Is this course a right program for me? and I put a ask. Again, it will take us a bit of time. You can see here now, if I go into July, the amount might increase here as and when I keep invoking with questions, right? So this is the answer. It says, I am a data science graduate. Is this course a right program for me? And it says, yes, this is a suitable program for data science graduates like you, blah, 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 right? So if you see, this is actually extremely powerful, because while you are working in an organization, you cannot have your company data on the internet, right? But I want to use the power of GPT. How do I do it? I will show you another small example. I have this content here, and this is basically a dummy content. If you see here, this is a legal agreement between a company called OLED Dynamics and another company, Tektronix, okay? Now, again, this is a dummy company. This is a dummy agreement. But what I will do is I simply copy this, come to ChatGPT. Now, instead of course, I put it in the contract. So I create a variable called contract. I put all of these. And what I will do is I will simply change the variable here. Again, it might take a few seconds for you. So it's just working on it. It's invoking the GPT API, getting things done. And now, if you notice here, in this agreement, I have some content on the deliveries, right? I have some exhibits. I have specification for the material one company wants to procure, about the quantity, about the delivery schedule, pricing. Now, if I go and say, hey, what would be the financial commitments? So basically, it works on that agreement, and it will give you the financial commitment on behalf of the company. Right now, these are legal agreements. If this, of course, this is a dummy agreement, but if this is a legal agreement, it belongs to your company, you won't be able to actually push it to the web, right? So you would like to download these APIs on your local computers or on your office systems, and then rebuild your models to work for you, right? And here it says what would be the financial commitment with it. It gives you a quarterly cost, an annual cost, and so on, right? So this is the power of using a large language model with your own proprietary data. Here. Now, this is what we have been using, and I showed you how to use the OpenAI's GPT. But the OpenAI's GPT is chargeable, as I showed you, right? And not always you would like to use it, because, for example, you want a chatbot to be integrated on your website. You might not be, willing to build a chatbot based on GPT, because for every query there is a cost to it, cost to the company. Of course, cost is a very subjective matter, but nevertheless there is a cost. What I'm going to show you here is another demo here. It's called Bloom. Now, what is this Bloom? It is again a large language model like GPT, but it's free, it's open source. You can simply download it, retrain it. Now, this Bloom is a pre-trained model. Now, I'm not going to run it because I have already built the model. So I will just walk you through the code, and I will show you how I have downloaded Bloom, how I have integrated or retrained the Bloom model with my proprietary data, uploaded into Hugging Face, and then I will show you the application on it. So here a couple of libraries are required. Those of you who are really technical, Bits and Bytes, LoRaLib, Accelerate. These are some of the libraries that are coming up, which are actually helping you build your model in a very optimized manner, because these models are really, really large models. I will show you a Hugging Face here. I log into Hugging Face. This is a platform which hosts all the models. So you see here, there is a library, there is a LLM called Bloom, which is coming from Big Science, and they have lot of models available for us. But some of these models are really very huge in size. So when you download them, it takes a lot of time. In fact, I subscribe to Google Colab Pro Plus, which provides me with a 40 GB GPU, right, along with some 170 GB odd spaces, and everything was occupied and it finally failed. So I had to move into AWS cloud, and then instantiate a server with a very high capacity memory, and finally use the Bloom's the largest model. Now, Bloom comes with 176 billion parameters. So larger the parameters, better the model it is in terms of the way it is trained. So what I have done is, in this demo, I have downloaded some of these libraries, and we are training we are loading a pre-trained model, meaning if I go to this Bloom, there are various models available under Bloom. And what we can do is we can exactly look for a model, because Bloom comes with various models. They come with a smaller model, they come with a bigger models. So what we have done is we have taken a Bloom 1v7 model, which this Bloom 1v7 model is just 1 billion parameters, just to demonstrate for a demonstration purpose. It might not work very well the way 176 billion parameters work. If you see here, this model which I have used to train my model is having 1.72 billion parameters, whereas the largest model from Bloom has 176 billion parameters. You can understand the time that it might take. But the good part is you don't need to rebuild this model, right? So you simply download this model, give your data, retrain your model, and use it. That's the power of it. So, so here it is. Now, I have imported some of the libraries. This transformer is something that comes from Hugging Face. Transformer provides thousands of pre-trained models. So really, you have various kind of pre-trained models available in Hugging Face. They have created a library called Transformer, where they have many models to use. They also have this auto class, meaning they have written various functions that provides various optimization functions that you can use to rebuild your model. I see there is a Q&A. Is there a link to this notebook? We will be putting it into GitHub, and I will be sharing it to you. Yeah. Okay. So also, we have something called LoRa config. This is actually another functionality that's those of you who are really into research or into technical, let me tell you, this LoRa is actually helping this computation to be much, much faster. LoRa stands for low rank adaptation, where it uses something called singular value decomposition or matrix decomposition for those of you who are maths oriented, and it can improve the performance of the model building drastically. So here it goes. And what I'm doing here is, here, if you see the code here, I will just zoom it. I am taking the big signs Bloom 7B1, which means it is a 7 billion parameters. I can also take 1B7. This was 1B7. But if I ask for Bloom 7B1, you see here, when I click on this, this model has 7 billion parameters, okay? So it's up to you what you would like to, given the kind of resources and the time which you have. You can download these libraries, the models. These models are pre-trained models. So I have already actually downloaded these models. I have also downloaded the tokenizer, the appropriate tokenizer that will be used to retrain our model. Now, what I have also done is I'm optimizing the model using, as I said, low rank adaptation and PEFT, which is used for fine-tuning our models. And there are certain configurations. Again, I'm not getting into these configurations at this point in time. We have a separate session on each of these configurations, explaining in a separate workshop that is coming up on July 8th. but overall, this is how you configure your model building performances. Now here, I also provide a data set. Now, what is this data set here? Let's go into Hugging Face. I will show you the Hugging Face data set here. You see here in the Hugging Face data set, this is a custom data set. Let us assume that this data set which you see is a custom data set which I have created and I have uploaded. And what I'm doing basically, I'm saying, okay, download the Bloom, take my data. Can you now retrain this model? All right. So that is what exactly being done. So this is my data set. And now I am actually rebuilding the model. I'm not showing you the retraining of the model here. It takes the transformers, it takes the model which I have defined, Bloom 7B1. It takes the data set, which I have again defined it. What it will do is it will go to Hugging Face, it will download Bloom 7B, it will download the data set, retrain the model. Now, after retraining the model, as you see here, I have been retraining the model. It takes a lot of time. That's why I have already built it, and so that we don't run it during the session. And then what I do is I connect to Hugging Face. I log into Hugging Face, and if you see the code here, model push to hub. What is this model push to hub doing? It is taking the new model and pushing it to Hugging Face. Now, why do I do that? I will show it to you here. Okay, now why do I do that? As I said, I will be developing a small app inside Hugging Face, which will talk to this model, our model. But before we go there, what I am doing here is Bloom 7B was downloaded. Our data set, which is uploaded in Hugging Face, is also downloaded. Not necessarily that you will have to have the data in Hugging Face. You can have it elsewhere as well. You don't need to upload it there, but you can connect your data and the model or the Bloom 7B that you have downloaded from Hugging Face, retrained your model. Now the model is uploaded into Hugging Face for my future use. And I have again downloaded that model from Hugging Face, right? So which means this is my model, AIM product ads. This is my model built on top of Bloom 7B with my data. Now I am using the fine-tuned model here. So I can now ask questions to the model. And here is where, if you go and see the data here, I have some data like I've just created some fictitious products, EcoGlow, or maybe, oops, let me just show it here, something like Glowmax, and I put a description. I've also given some advertisement strings just to train the model. So which means I have created a data here. I have created some fictitious product, an appropriate description, an appropriate ad. Now what I'm doing with this is I am saying, okay, now this Bloom 7B is downloaded and retrained on this particular data which you see on my screen, and a new model is created. Can I use that new model and ask something which is related to either my products or similar products, or even I can use probably products which is outside my domain. So here is where, if you see this particular thing, I'm saying product taken from the training data set, meaning this is my training data set. Yeah, Bloom 7B1 did not know about these products earlier. So I have taken and I said, okay, can I take some product risk take, which is existing, and I'm giving a description for the product, and this particular product and the description is already existing in my training data, and I am saying, can you create an ad for me? Obviously, it will create because I am taking a product and a description from the data set. But now what I'm doing is product taken from outside the training data set, but a similar product. So I take a similar kind of product, because if you see in my data set, all the products are kind of electronic products, right? Glowmax, Ristake, iVision, whatever it is, right? All are kind of electronic consumer products. So what I do here is I take a similar product, maybe a solar watch, and I say a watch that won't need you to charge, right? And I say, can you create an advertisement here? And it creates an advertisement. So let me just copy it and add a cell here. Um, let's see what is the ad it has written. So it has written an ad here, which says, keep your energy cost to a minimum, save on your power bill with solar watch, the ultimate watch that needs to be charged, etc. Blah, 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 right? So again, Bloom did not know about this. Now you might ask, if I give this to ChatGPT, will ChatGPT not be able to do it? Will Bloom be not able to do it? The answer is yes, it will be able to do it. But the question is, does it know about my products, which I have not disclosed it yet? Does it have the information which I am not willing to share it with the outside world? It doesn't know. So if I can train these pre-trained models with my proprietary data and use these large language models the way you use otherwise, right? It will give you more relevant information. It can create content that is more relevant, more specific to your business domain, right? Satej, I will just get back to you on the what Satej has a question. Like, I see, what does 8-bit mean and how does LoRa work? I'll get back to you on this. Maybe we can take the Q&A post this session. Of course, how does LoRa works? It would take a bit of time, but I will try to explain it to you in a short span of time. Now, what I have also done is I wanted to really test my new model rigorously, right? So I have taken a different product altogether, and I said, hey, can I take a Nike shoe and say, what a comfortable run, and can I create the ad for it? The point is, yes, it will be able to create, provided it knows the product well, right? Now this new model is trained on whatever 7 billion parameters it was trained, plus it is trained on my data, right? The one which I have uploaded. Does it know Nike shoes? Probably it knew already. What if there is a completely new product? We don't know how it is going to perform. Now, let me tell you here, building the model, giving the data is no big deal. It's a few lines of code, we can do it, we can use it in our organization, but the challenges will come in fine-tuning the model. The challenges will come in performance when you have to download a very large language model like Bloom 176 billion parameters. It's a huge mind-boggling model. How do you really download it in your computer systems or wherever? Even if you're using a cloud system, you might require a lot of resources doing it, right? So you got to know, like Satej, I see Mr. Satej is asking a question, how does LoRa work? So those are some of the optimization techniques and parameters we need to use to build this model in a much faster time. And there are various communities and companies who are working towards it to come up with a new way of working, fine-tuning the models, writing optimized codes. For example, I will show it to you in my next demo, that we are using something called Accelerate from Hugging Face. They have done an excellent job in writing this piece of library that speeds up your computation extremely fast. So this is how things are working. Now, what I have done with this model is, coming back here, in Hugging Face, there is something called spaces, and I have created two spaces. One is craft ads for my products. So the model which I've just shown you, right? I have uploaded that model into Hugging Face and have created a UI, what you see on my screen. And if you see here on the right-hand side, it says AIM product ads, Quest Learning AIM product ads. And this is the ad, this is the model which we have built using Jupyter Notebook, using Bloom and our own data, uploaded to Hugging Face. And I created this UI. And if I now, suppose I say solar watch, I write something product, and you will not need to charge your watch again. I submit it. it creates an ad and it shows it to you in a very proper usable manner. So if you are creating if you're creating a POC, proof of concept, for your organization or for yourself, you can actually do it almost free of cost, right? Download the models, give your data, rebuild the model, put it to Hugging Face, and creating this UI in Hugging Face takes 2 minutes. Just 3 or 4 clicks, 2 minutes, you are done. Of course, you need to know a bit of settings. Like, for example, if you see here, I have this settings here, and it says it is running on NVIDIA T4 small server. Some of the models, whether it is a large language model or image models, it will require GPU. So if I try to run this model on a CPU basic or on a CPU upgrade, it will fail. So from that point of view, you need to know a bit of, a little bit of technical things, where, like, which model requires a GPU, which model requires a CPU, and all of this. And it will just be a cakewalk to deploy these models and build an application on top of it, give it to your users to test. Because not necessarily the Bloom or whatever large language models you have pulled down, rebuilt, or retrained your model with your data will work as per your expectation, right? You might have to do a lot of fine tuning. Who knows, right? So somebody has to test your new model. So this is a very good way to test your new model. Now, let me show you one more demo, which will take just 5 to 10 minutes. Again, it did require a Pro Plus to rebuild the model. Here, what I'm doing is, Bloom is a large language model. You give it text, it will give you text. What we have done here is we have used stable diffusion. Give text, get image. But here what I have done is, I will just show it to you. There is a good piece of code here, and I have used Stable Diffusion version 1.2. There are more advanced version of Stable Diffusion. Of course, the more latest versions are more big in size. It takes a lot of time to build this model. It required me almost 30 GB of GPU usage, right? I also have my custom data set. So I have created a data set on women's clothing. And if you see here, this is my data set. And Hugging Face allows me to create a data set like this, right? So I have some strings to tag with the images. And I have taken all the women's clothing, different kind of clothes, right? If you see here, and I have put a tag saying East Side, some branding. I have put it, and I have this data set card with me. What I have done is I have taken the Stable Diffusion. So let me just copy this, go to Hugging Face, and I type this. You see Comp Diffusion, Stable Diffusion version 1.2. Again, as part of the Hugging Face transformer, this model is available. So you can simply download it, retrain your model. Now here is where Accelerate. This Hugging Face Accelerate library is the one which I was talking a few minutes back. It takes care of the heavy lifting. So you don't have to write any custom code. Run your training script using Hugging Face Accelerate. And of course, you will have to understand these parameters a bit. Again, this is as part of our workshop that's coming up from likely in July or August. And this is something which speeds up the activities a lot, right? So I'm using this, and then I also have a data set, and I say, okay, can you take the data set? Can you rebuild the model? So what I have done is, here I have given an output directory. This will become my model name in Hugging Face. So if I go to my Hugging Face, and if I try to see my model, you see here, these are my models available. This is the model I have, right? And I am taking that model now, and I have given some prompts. You see here, let me just zoom it a bit. You see some of the prompts. So what I have done, I pull down Stable Diffusion. I have my data set, rebuild the model. I've uploaded into Hugging Face, downloaded it back using some prompts here. And I am saying once the image is generated, you can save it locally into with these names, image 1, image 2, image 3, etc. So what it has done is, see, it took a bit of time because it has to download and the prompt engineering works behind the scene. And it has created data which is very much aligned to the kind of images you upload, which means the model which you have trained, all right? It will talk that language. Now, you might say, oh, I might get these images from the standard model also, Stable Diffusion. The answer is yes. But the focus here is I'm taking that model, I'm retraining and fine-tuning it towards my data, my images. So when I say that, okay, can you generate images? Now, if I go here, you see, I have uploaded an app and I say, okay, can you give me a blue kurta with white polka dress by East Side. Now, this is where the prompt engineering will work. Now, let me try to see what comes. It might take a few seconds. This is the model which I've uploaded into Hugging Face and again created an UI for us to test how good it is working. And the magic will be the East Side, right? So if you see the data here, my text contains some description for these dresses. So it's a combination of the image and the combination of the description. Along with that, my new model is retrained. And here it is. Let's not go by the face. It is, but this is the dress you get. But if you see the background images and all this, it probably will look into your background images and try to generate very similar to your data, right? And that's what we wanted to show here, like how you use up already existing models. And let me tell you, there are a lot many large language models. It is not about just GPT or BARD. There are a lot many. And some of the models are really free. They are large and they are doing a wonderful work. Similar to large language models, you have a lot many image models, and Hugging Face is one of the place where if you would like to explore, you get almost all the models that are available in the market in Hugging Face. You just go and search for it, and using Hugging Face is quite simple. Just that, yes, you need to have a bit of resources. Hugging Face is not a platform to rebuild or retrain your model. So you need another environment to retrain your model. And that's the reason why we have used Google Colab, where we connected to Hugging Face, brought down the model, retrained the model, pushed back to Hugging Face to make it work. That's pretty much, but all said and done, how does ChatGPT combine with Stable Diffusion model you have created? Okay, so Satyaj, let me tell you, we haven't connected ChatGPT with Stable Diffusion. We have created a separate model based on a large language model, a separate model based on a text-to-image model. We haven't combined it. But also, ChatGPT is not yet capable to handle images. Okay, but what you can do is, in case you want to build something, you can probably have an output from an LLM which can go as an input to your text-to-image model. I hope this is clear. You understand what I'm saying? Like, because whether it is a large language model or whether it is a text-image model, the input is text, right? The input is text. So even a text-to-image model is taking input as a text. So a tokenizer works at the back end to generate the text, understand the text, and then generate the image from it, right? So to be specific to your question, we haven't combined it yet. Okay, now I will just show you a few things on our prompt engineering thing, but all said and done, as I told you, whether you are using LLM or you are using text to image model, the input is text, which means garbage in, garbage out. I give a wrong text, I get a wrong output, which means what we also need beyond building this model is prompt engineering. Now, I will very briefly touch upon prompt engineering. Whenever we talk about prompt engineering, there are many things, but there is a zero shot, few shot kind of prompts, but we are not getting into there. I'm just getting into 4 components of prompt engineering, which says instructions, context, input data, output indicator. If you follow these 4 components in prompt engineering, whatever models you built, whether it is a text-to-image model or a large language model, if you follow these 4 components while writing your text as that goes as an input, right, your output will definitely be better. So it is not just a large model. It is not just your data. It is not just how well you fine-tune your model. And it is not just prompt. It is a combination of all of this. I need a good large language model or a good text-to-image model. I need a good data set if I want to retrain that model. I will have to configure my parameters in order to fine-tune the retraining of the model. And then when I use my retrained model, I will have to give the right prompt to it. Even for ChatGPT, right? This is applicable, right? So I have just taken an example here for instructions. Suppose I say, compose a persuasive email requesting a salary raise for your upcoming performance review. So I'm giving an instruction, right? Compose a persuasive email. That's the instruction. And I'm setting the context that you work as a software engineer at a tech company and have been working with the company for 2 years. Performance review is approaching. You believe it's an opportune time to negotiate. Then I provide an input data. Now, this input data might be, you see your current salary, your achievements and contributions to the company, and so on, right? Any notable accomplishments. This goes as an input. And then in the output, you might very specifically say the email should clearly outline what? Maybe your achievements, justify your request, demonstrate some kind of enthusiasm and commitment, and so on, right? Now, if you see, this gives a very holistic view to the model, right? The model gets to understand your prompt from multiple dimensions, right? It gets the instruction, you set the context, you set your roles, and you give the input, and then you also say what precisely you need as an output, right? So this is what a prompt should be ideally. So coming back, building this custom models with your proprietary data combined with the right prompt engineering can do wonders for you, which probably publicly available models like ChatGPT or something which you are using now might not be able to do it for you. And as you also asked, like, can I combine an LLM and text to image? Yes, there is a way to combine both of this large language model and the text image model as well. You will have to do a lot of custom work for it, but this is doable. Well, that ends my presentation here. If you have any questions, please do let me know.